Hello, this is Keith Baxter. This is my second video on how to hack the Zen Flute. And here I'm going to work with a very simplified version of the program that's really set up for people who want to build their own synthesizer, do their own sound design, but would like to use the front end of the MIDI flute to extract, or the Zen Flute to extract pitch. So basically, this will be on the website. It's going to be called Template. And what I've done is taken out all of the flute synthesizers, which is massive in there, and put in a framework, a scripting language framework for building a synth. And I'll show you that real quickly. It starts right here, and here's the website that shows where to look at this thing. Basically, this scripting language, if you were to copy this little section here and go to that website, I'll show you what that looks like. And import it using this green button, you'll get this picture, which is basically a picture of the synthesizer that's in this template version. So you can see there's a little waveform generator, an envelope generator, mixers, filters, things that if you're used to synthesizer construction, these are pretty common. There's a USB output, which is the audio going out the USB cable that comes with the Zen Flute. And then this output is the audio output out of the side mini phono jack. There's a couple DC levels which just happen to be connected to a mixer because they need to be in order to work. Has to be connected to something. And you can use these to build sort of automated ramps and up and down ramps if you need them. Anyway, so you can take a look at this. You can build these things if you click on one of these functions. You'll see over on the right hand side there's a little description of the calls you can make to it. So this is a reverb, and you can change the room size. Damping, as you might expect from envelope, you can change note on and off. You can turn the note on and off, and there's controls of the classic delay, attack, hold, decay, sustain levels, etc. A lot of fun. So that's there. This is what's in there right now. You can pull that stuff out, put whatever you want in there, and go with that. So that's the first thing that's in here, and that's kind of interesting. A lot of variables that are set up. You don't need to look too hard at those. One thing I've done that I think is useful, as you know, the way these things are set up, there's I make a global variable section, then there's a setup that runs once to get things set. In that section, you can set your envelope delays, you can set your mixer gains, initial values, and the like. At the beginning, then the main program is just basically a loop that keeps going around and around. And I've put in here a little debug section, which I think would be useful when you're just getting started. If you remove the comments from, let's say, Roman numeral 2, this will print out values of the push button, which is cherry 1, or in the raw values of the joystick. So you can take a look at those, and you can test your system and also see what kind of values you can play around with when you're building your synth. So I'll basically compile this real quickly so you can see how this works with the Teensy serial console. So you invoke that console up here to the right. It's called serial monitor. Push that button. Well, maybe wait till it's finished compiling, and then it's done. So you push that button, and the console opens up, although it's kind of small right here, but you can see when I slide the window up, you can see there's a push button value, and the raw joystick values are there. If I push the push button in, you can see it goes to a 1, which is the on state, and if I move the joystick around, you can see those numbers change. For example, the first joystick value is front back, the second one is left right, so it's going from about 255 to about 0, but not exactly, because that's the way electronics is. Anyway, that's kind of useful. You can test it, give you a feel of the variables that are within your control for making a program. If I comment that out and remove the comments from Roman numeral 1 and compile that, I have some other variables that are more continuous that you can also work with in building your synthesizer. And these are basically the frequency values that are extracted from moving your mouth using the Zen Flute front end. So that is invoked by going up to the right hand corner. It says serial plotter. Click on that, and it opens a little window. and you'll see a green line and a yellow line. One's the actual frequency and the other is the quantized frequency. I'll just play that real quickly. So you can hear the mouth speaker there. You can't hear any synthesizer because I don't have it plugged into anything that you can hear. But you know, basically give you an idea of what's going on, let you look at it again, test it, and see what those variables look like. So I'll just shut that down. Other than that, you want to basically go to this section, and you're going to see this is the beginning of all the code that does the mouth measurement, and you're welcome to mess with this too. And maybe I'll do a video on that. But if you just want to say, I just want that frequency value that you've extracted, and I'm going to work with that. I want to build sound. I want to build a UI that I really like and get the notes and the scales that I like. Then just skip down to begin UI, which is labeled right here. And when you get down there, you'll get through all this like extrapolation kind of stuff. And right above begin UI, there's a list of the variables that will have been extracted by this above code. So now frequency is your raw frequency that you're playing. These other ones are pointers to scales. So by changing these scales, you can make some notes legal and some notes illegal when you're playing. So that it plays, say, a chromatic scale if every note is going. If you want, you can disable that and play everything, microtones and all. I can't do that, but you can do it because here it is for you to use. In that case, you use now frequency. In the UI, I've just thrown in some stuff that I think is useful, but mostly there's nothing here. There's some things that turn on the mouth speaker when you start, that turn the system off when you've stopped. When you press the joystick button in, you get a change in mode, which in this case maps to different scales that you can put whatever scale you want in by messing with these scale filter variables, which I described in the earlier video. Checking the debouncing the button on the flute. And here's really the only thing that's in here right now, which is when you push that button, it loads the chromatic scale filter hysteresis closest scale number, which is the frequency that I've been using, into that waveform block that I showed you earlier in the scripted synthesizer layout, the graphic layout language. Envelope 1 is turned on. Asked to kick out MIDI. You can do that. It comes right out the USB cable. Here if you change the pitch afterwards and you still want to follow that pitch even though you haven't pressed the note button again, this is after touch change that you can use. And here the key is released. You can see the envelope is turned off, and the MIDI notes are zero volume set out over the MIDI. I think that's pretty easy. It's very short. It's nothing here that you have to leave in here. It's just a bit of a framework so you can get started on there. The joystick is periodically sampled because you don't need it that fast, and you can put whatever you want that joystick to do in here. It can send MIDI commands, it can do vibrato, it can interact with any of those blocks that you put together in the graphics synthesizer language. And the flute, that's it. The rest of this stuff is some functions. Just real quickly, this is an interrupt service routine to grab the data I need for mapping your mouth frequency out. You don't need to be involved in that. Color just changes the color of the LEDs. There's a map float function, which doesn't seem to be part of the Arduino typical instructions they have, but it's basically a mapping function that lets you map from one range to another. And there you go. I hope that's enough to get you started. I do talk in an earlier video about how to get this IDE loaded and ready for the Teensy, which is the microprocessor used on the flute. So you might want to look for that if this seems completely mysterious. Thanks.